is about. So before understanding the robotics, we need to understand three key elements of the need. So there are three main elements of the key need. One is the morphology, the articular surface, shape of the shape of joint and the joint line. The second one is soft tissue. So morphology, soft tissues have good relationship. That is decided only one by one correspondence. Okay. So once morphology decided, the soft tissue balancing is the patient own soft tissue balancing. In the same time, soft tissue, once soft tissue is decided, the morphology is also decided. So-called forward linkage theory. And alignment. Because the femur and the tibia are long bones, so we need to consider about alignment that can affect the load transmission. So anyway, there are three key elements that make the good harmony of these elements. So the one element decides other two elements, and one element is decided by two elements. So by three elements, the patient own kinematics is constructed, decided. Okay, so this combination is the difference among the patient. And because morphology is very different from patients, and the alignment is different among the patients. So maybe we are aim to the same goal to the patient own kinematics or patient native situation. But starting point is different. So start from the morphology. It is a kinematic alignment or true kinematic or calibrated kinematic. And if start from soft tissue, is soft tissue respecting or functional alignment. So this is based on the soft tissue balancing. And third one, how to control the alignment to avoid extreme alignment, such as more than 5-degree impedance. That is the restricted kinematic alignment. Anyway, they are aiming to the patient native, the patient own condition, including kinematics. But using robot, we can evaluate every element intraoperatively. And in the same time, we can manipulate three key elements simultaneously. So that is the advantage of usage of robotics. So without robotics, hopefully we can decide the one element. For example, caliper, we can only see the ball cutting thickness and more morphology. So using soft tissue respecting, we cut the bone based on the soft tissue balancing. So restricted kinematic alignment requires some computer devices such as PSI robotics. But anyway, robot can manipulate, control all. So that is the benefit of the robotics. So how to do the robotics, use the robotics? My priority is alignment, maybe. The second one is morphology. The third one is soft tissue. This is my priority. So basically, my procedure is the restricted kinematic alignment. Preoperatively, I measure LDFA and MPTA and HKA. And HK is arithmetic HK. Of course, I always measure the mechanical HK. Mechanical HK means the angle between tibia mechanical axis and femur mechanical axis on the standing position. But arithmetic HK means the joint line, the HKA, when the joint line comes to parallel. Okay, that estimates the patient native alignment, and in the same time, it implies the post-operative alignment if the procedure is true kinematic alignment. Okay. So, because this is the one report from Australia, the arithmetic HK nearly equal constitutional HKA. So we can consider the arithmetic HK as the patient constitutional HK. Of course, but it is too much bias or too much bias. We need to adjust it. We need it to control. In the Asian country, so many patients have the very severe varus alignment, especially in the osteoarthritis patient. So I hesitate to do the true kinematic alignment naively. So I want to control a little bit, but plus minus 3 degrees too small. So I decided the safety range at least be plus minus 5 degrees. But I think around 6 degrees can be applied. Anyway, so limitation or boundary is not decided so far. Anyway, so arithmetic HK equals we can consider as the constitutional HK. So my plan, this is my plan. Then, so using the LDFA and MPTA, I plan the cutting angle of LDFA and MPTA individually, then calculate the arithmetic HKA, and that is 2 beta sarcophagus. I make the second correction. So, for example, LDFA is 5 degree in betas, and MPTA 5 degree in betas. The totally 8 HK should be the 10 degree in betas. It's too steep, so in this time, I adjust the femur side up to less than 3 degrees in valgus and 6 degrees in betas. There is no evidence, but it is my feeling. Because betas, post-operative betas alignment can be accepted than the valgus alignment. So we need to avoid the valgus alignment post-operatively. Anyway, so I decide the preoperatively. So then there are 2 cut options in terms of tibia cut. Of course, we can cut the tibia as planned, so-called restricted thematic alignment. Another one is decided the tibia cutting frame based on the laxity. So after the bone cut, I implant, I put on the femur, put the trial component on the femur cutting plane and apply the valgus stress. That is the intraoperative stress HK. That should be another goal. So I consider intraoperatively in both preoperative planning of the tibia cutting angle, and intraoperative HKA. Then we can estimate the best cutting angle of the tibia. Anyway, it's such question. How to do this? LDFA should be the safety range, should be in the safety range, because that is plus minus 5 degrees. And MBTA is out of safe range. So I reduce the MBTA by 5 degrees in Vegas. And the posterior slope is steep, too steep as well. So I reduce it to the 7 degrees. Then that is the planning. So we can set this value on the screen. So in a femur cut, I think this is the ideal because I planned femur cut at 3 degrees in Vegas. So 3 degrees in Vegas. Of course, we can adjust this one. But have a look. The distal cutting thickness, distal cutting thickness. Always for the medial side osteoarthritis, lateral cartilage is virtually normal. So the cutting thickness set as 9 millimeter. Okay, but in the medial side, there is the cartilage and bone loss. There might be the cartilage or bone loss. So it cannot be decided precisely, but lateral side, we can decide cutting thickness precisely. So the concept of kinematic alignment is to cut the bones of the same thickness as the component. Then the preoperative joint line can be restored. Then, if once I decided the lateral side cutting thickness at 9 degrees, medial side should be 2 millimeter thinner. But this case is 7 degrees. It is the idea. But sometimes it's the screen displays the medial cutting thickness as 5 millimeter or 10 millimeter. There is a contradiction in practice. How to resolve this? Anyway, I believe the cutting alignment 3 degrees. But as you know, so this value is depend on the registration point in the intraoperatively, more practically saying, so put on the paddle and touch the both distal condyle and both posterior condyle. The 4 points at the same time. You need to paddle in the very tight, small operation field. So sometimes it can lift up and away from bony surface. Sometimes push, then cartilage can be shrinked. So maybe I believe the cutting thickness is not so accurate. So how to do this? I use the caliper, measure the cutting thickness in the real world. Okay, so even this computer Rosa sprays the media cutting thickness is 8 millimeter, but I use the stylus, adjustable stylus, and measure the lateral cutting thickness if it is 9 millimeter, and media size 10 millimeter is okay. But this is 3 degrees. If I manipulate this angle a little bit, for example, on the preoperative LDFA is 91 degrees. It is the best. Recently, I want to avoid the varus LDFA because a femur joint line should be a little bit bulbous, in average to around maybe 2 degrees in bulbous. So, varus LDFA is considered to be in the abnormal. Maybe it includes not only the cartilage but also the bone loss. The amount of bone loss cannot be estimated precisely so far. There is no way to estimate the thickness of bone wear. So at that time, if I control a little bit valgus, so medial side cutting thickness should be thinner. Do you understand? If you cut more valgus, for example, for 6 millimeter or 5 millimeter, we need to make the cutting plane more valgus. If you make the valgus, if you cutting plane to more valgus, for medial side cutting thickness should be more thicker. So if this case there is no manipulation in terms of LDFA, so ideal cutting thickness should be the 9 and 7. But I want to cut more valgus. 7 millimeters should be 6.5 or 6 or sometimes 5 millimeter. It depends on the correction angle. Do you understand? Okay, so anyway, estimate and measure again and again. Then I satisfied. Of course, in most cases, so every measurement cannot be ideal. But some plus minus 0.5 degrees and plus minus 0.5 millimeter can be accepted. Anyway, so femur cut is truly depend on the morphology. So for the measure the cut, to make the patient the native articular. まだ過ぎてた。ごめん。なんかちらっとにやれたね。最後まで説明できなかった。